Hi everyone, welcome back. So finally is the last video for your chapter 6, which we will discuss on Chatellier's principle. So Chatellier's principle is a principle where it states that when a system in equilibrium is being disturbed by certain factors, it will try to reduce the effect of disturbance to retain its chemical equilibrium. So there are 5 factors that you need to learn which will trigger the systems in chemical equilibrium, which is the first one: temperature, concentration, volume, pressure, as well as addition of inert gas. So first, we're going to discuss on the changes in concentration towards the systems in chemical equilibrium. So changes in concentration, you will encounter to 3 different cases, which is first when we are increasing the concentrations of a compound present in your chemical equilibrium. Secondly is decreasing the concentration, and thirdly, completely removal of the compound. So we completely lost the compound from our chemical equilibrium. So just to highlight to you, changes in concentration will give no effect towards the temperature. So that means it will not affect your value of equilibrium constant. Okay, so it will only just affect the positions of equilibrium and how does the system respond to re-establish the chemical equilibrium again. Okay, so first let's discuss on increasing the concentrations of a compound. So when we increasing the concentrations of the compound, the part that we increase will causes the concentrations to be heavier, whereas the other part to be lighter. So if we draw a seesaw, it will not be a balanced seesaw. One of the side will be heavier and one of the side will be lighter. So let's have this ammonia process of production, Haber process, as an example. So let's say I'm increasing the concentrations of my nitrogen gas. So if we draw a seesaw, nitrogen gas part will be heavier, whereas the ammonia part on the right side will be lighter. Okay, so in order to achieve or retain the equilibrium, the systems will need to produce more ammonia until the system retains its equilibrium. So our disturbance is increasing nitrogen concentration. So systems will respond by using nitrogen gas to produce more ammonia until equilibrium is established. Okay, so positions of equilibrium. So I'm going to use the short form till the end of my video. POE stands for position of equilibrium. Okay, so position of equilibrium will shift from the heavier part, which is on your right side, to left until Q equals to K. So that means NH3 concentration will increase, whereas nitrogen and hydrogen concentration will decrease. Okay, so what happens if I decreasing the concentrations of the compound? So the part that we decrease the concentration of the compound will become very light, whereas the other part will become heavier. So I'm going to use the same chemical equilibrium, which is the formations of ammonia in the Haber process, as your reference. So let's say I'm decreasing the concentration of my hydrogen. So my disturbance here is hydrogen concentration drops. So systems will respond by reproducing more hydrogen because the concentration is being dropped. So we're going to produce more hydrogen. So if we draw a seesaw, okay, so this part which is containing your nitrogen and hydrogen will become very light, whereas at the nitrogen part will becomes heavier. So system will shift from the heavier to the lighter part so that we can have an equilibrium system which both sides having a similar weight. Okay, producing more hydrogen. So POE will shift from the heavier part, which is on your right, to your lighter part to the left until a new equilibrium is established. Okay, where Q equals to K. So what happened then? Nitrogen concentration and hydrogen concentration increase, but concentration of ammonia is decreasing. Okay, let's look at the third cases where we completely remove a compound from the chemical equilibrium. So completely removal of the compound means we lost the compound from the equilibrium. So that means to retain the equilibrium, we need to reform or reproduce the compound that we removed from the system. Okay, so again, I'm going to use the same chemical equilibrium. So let's say I completely remove my ammonia. So my disturbance is removing ammonia. So it means I lost this ammonia from the chemical equilibrium. So the systems will respond by producing ammonia. So ammonia is on your right side. That means positions of equilibrium will shift from left to right until equilibrium is re-established. Pardon me with my bad handwriting. Okay, until Q equals to K. So what happened? N2 and H2 concentration will decrease, okay, in a simpler words, whereas NH3 concentration will increase. Okay, so let's try now with a different example. So this numbering question 5 is just simply because I continue the numbering from my previous video, which is to compare Q versus K. Okay, so you have this chemical equilibrium, but in the chemical equilibrium we have solid, which is your sulfur. So any changes in the concentration of your sulfur will not affect the system in equilibrium. Why? Did you remember why? Because, okay, it is a pure solid, which does not appear in your Q and K expression. Okay, so same goes on with any pure liquid that is present. So changing in the concentrations of a pure solid and pure liquid in a chemical equilibrium will not affect its positions of equilibrium, so we can just ignore it. Okay, so but the first question is asking what will happen to the system in equilibrium if oxygen is added. So adding more oxygen means the disturbance is increasing concentration of oxygen. Okay, so if we draw a seesaw, we will have a heavy part on the hydrogen sulfide and oxygen part on the left side, and the lighter part will be H2O gas. So we want this chemical equilibrium where both sides stays at the same level. So that means we're going to shift the equilibrium from left to right until oxygen and H2S having a similar weight in total with the water vapor. So system will respond by using oxygen gases, okay, until equilibrium is re-established. So positions of equilibrium will shift from left to right until Q equals to K. Therefore, concentration of H2S and oxygen will decrease, whereas concentration of my H2O will increase. Okay, what will happen then if we had added more H2S? That means the disturbance is increasing H2S concentration. Okay, so what will happen? So if we draw a seesaw, you will have a heavier part on your left side, which contain your H2S and oxygen, whereas your H2O gases will be the lighter part. So in order to retain the equilibrium, which means both sides having the same level, Okay, so the system will shift from the heavier part to the lighter part, which is from left to right. So system will respond by using H2S until equilibrium is reestablished. Okay, so POE will shift from left to right until Q equals to K. So POE is the short form for positions of equilibrium. If in the exam you are not allowed to write down a short form, so you need to write the full sentences, which is positions of equilibrium. Okay, so therefore H2S and oxygen concentration will decrease, but H2O concentration will increase. Okay, what happened then when we completely remove H2S from the chemical equilibrium? That means we completely lost this H2S from the system. So definitely your chemical equilibrium is being disturbed. So the disturbance is removal of H2S. So your system will respond by reproduce the lost H2S. Okay, so positions of equilibrium POE will shift from H2S is located on your left side. That means we're going to shift to left. So from right to left until an equilibrium is established at Q equals to K. So therefore, H2S concentration increase and oxygen concentration increase as well. But H2O concentration will decrease. Okay. So then, what will happen when you add water molecules? So adding water molecules, that means we are increasing H2O concentration. Okay, so systems will respond by using the additions oxygen. Okay, system will respond by using the increasing concentration substance, means by using H2O until an equilibrium is re-established. Because if we draw a seesaw, you will see the side that having water is become heavier. Okay, and H2S is on the left side, which will become lighter. So in order to retain the equilibrium to get both on the same level, we need to use up the heavier part, which is your water. So we're going to produce more of H2S and O2, so adding more of this. That means systems in equilibrium will shift from right to left. So POE, positions of equilibrium, will shift from right to left until Q equals to K. Therefore, H2O concentration decreases, whereas both H2S and oxygen concentration increases. Alright, so I hope I already give enough explanation and guidance for you to understand the effect of changing concentrations towards the systems in equilibrium. Again, I would like to emphasize to you, it will only affect the systems in equilibrium, means positions of equilibrium. So effect of concentration will never ever change the value of equilibrium constant, because the temperature is being kept constant. Alright guys, so we already discussed on the changes in concentration. Now let's discuss on the second factor, which is the changes in temperature. So changes in temperature will only involve two different cases, which is either you increasing the temperature or you decrease the temperature. Okay, so just to let you know, changes in temperature will affect the value of your equilibrium constant. So either it will increase or it will decrease. So I'm going to elaborate further after this about the changes in the K value. But let's now talk about the changes in temperature first. Okay, so when we increase the temperature, we are adding more heat towards the chemical equilibrium. Alright, so when we are having more heat, that means the system will respond by trying to absorb that excess heat to retain the equilibrium. So the process which absorbs heat is known as endothermic process. Endothermic, which absorb heat. Whereas if you decrease the temperature, so the system will try to produce more heat. So the systems in equilibrium will try to restore its equilibrium by shifting to the side which produce more heat, and that reaction is known as exothermic reaction. Okay, so like I told you, increasing temperature, we have more heat, excess amount of heat. So the system want to absorb that excess heat. So the positions of equilibrium will shift to the side that is your endothermic reaction. Whereas if you decrease the temperature of the system will respond by producing more heat to retain its equilibrium. So it will shift to the side which is exothermic reaction. So which side it will shift? So which side does the positions of equilibrium will shift? To the left or to the right, depending on your chemical equilibrium. Because some chemical equilibrium will have forward reaction to be endothermic, whereas the reverse reaction to be exothermic, or some systems might have the forward reaction to be endo and the other side will be exo. So it entirely depends on the given chemical equilibrium. Okay, so the changes in temperature is the only factor which will change the value of your equilibrium constant. So there are two cases. So your value of equilibrium constant will either increase or decrease. So it depends on which reaction does the positions of equilibrium shift to. If we produce more product, so that means your value of K will increase. So more product means K will increase. But if the positions of equilibrium shift to the reactant part, so that means we are having more reactants, less product. So your value of K will decrease. So value of K determines by amount of product produced. More product, K increase. Less product, K decreases. Okay. So let's look at this question 7. So we will discuss on these 4 different chemical equilibrium. So how are you going to know either the reaction is exothermic or endothermic for the forward reaction? You have to refer to the enthalpy value given together with your chemical equilibrium. So for your information, all the delta H value here will represent forward reaction. Okay, so if your delta H is negative, that means the forward reaction is exothermic. Exothermic means releasing heat. Okay, so if your delta H is positive, that means your forward reaction is endothermic, and that one is absorbing heat. Okay, so I really wanted to emphasize to you, please make sure label at your chemical equilibrium under your reversible arrow which side is exo, which side is endothermic to guide you. Okay, if you don't labeling your reversible arrow with endo and exo, you might get confused somehow. Alright, so let's look at the first equation, which involve your calcium oxide with water liquid. Okay, so the delta H given here, enthalpy is negative. So negative means your forward reaction is exo. Exo doesn't mean exo the K-pop group, but exo here means exothermic. Okay, and the reverse direction is endothermic. Okay, so question here, what will happen when we increase the temperature? Okay, so like I say, increasing temperature, that means increasing temperature, excess heat is present. So when excess heat is present, system will try to respond by absorb heat. Respond by absorbing excess heat, which means it will shift to the endothermic reaction. So that's why I wrote here endothermic reaction favorable. So your forward reaction is exothermic, whereas your reverse reaction is endothermic. So positions of equilibrium will shift from right to left, which is towards your endothermic reaction, until equilibrium is re-established and Q equals to K. So you have to mention all of this long explanation to score well. So what happened to your value of K? So since we produce less product and more reactants, so value of K will decreases because the amount of product is decreasing. Okay, what will happen to the concentration of the underlying compound, which is your calcium hydroxide? So calcium hydroxide will decrease because the reaction system shift to the endothermic reaction. Okay, let's look at the second example. So we have here calcium carbonate decomposed to form calcium oxide and carbon dioxide. So the disturbance here is increasing temperature again, and your delta H is positive, means your forward reaction is endo, so level on your reversible arrow, and your reverse reaction is your exothermic. So increasing temperature means having more excess heat. So system will respond by absorbing the excess heat. System will respond by absorbing excess heat. Means it will shift to the endothermic reaction. So which side is your endothermic reaction? It's from left to right. So therefore, POE will shift from left to right until Q equals to K, or until an equilibrium is being re-established. So what will happen to your value of Kc? We are producing more product. Okay, so more product means Kc increases. Okay, and the concentrations of the underlying compound, which is your carbon dioxide, will increase as well because we are shifting to the endothermic reaction, which is the forward reaction, and carbon dioxide is on your product part, so that means carbon dioxide will increase as well. Alright, so let's discuss on the next question. So we have here carbon, which is your graphite. So this one is actually in the solid form, reacting with hydrogen gas to form methane. Okay, so we're going to discuss what will happen to the concentrations of hydrogen gas at the end. They give you the delta H, or enthalpy of the reaction, is negative, means your forward reaction is exothermic. Exothermic, release heat. Okay, release heat. And your reverse reaction is endothermic reaction, which is absorbing heat. Okay, so the disturbance is increasing temperature. So increasing temperature, endothermic reaction is favorable. Okay, because we want to absorb the excess heat that is present. So forward reaction is exo, based on the given enthalpy value, and reverse reaction is endo. So write the full term, exothermic and endothermic. So system will respond by absorbing the excess heat, which is endothermic reaction favorable. So positions of equilibrium will shift from, so your endothermic is on reverse reaction, so from right to left until equilibrium is re-established and Q equals to K. Okay, so since it shifts from right to left, That means we are producing less product but more reactant. Therefore, your value of Kc will decreases because the amount of product is decreasing. So what will happen to the concentrations of hydrogen? Since it shifts to endothermic reaction, which is towards the left, and hydrogen is on your left side, that means hydrogen concentration is increasing. Okay, so how do you find it? Is it difficult or is it just fine? Okay, you just need to remember what will happen when you change the temperature, either increasing or decreasing. Okay, so increasing will favors the side that absorb the excess heat, because increasing temperature, it means you are adding excess heat towards the chemical equilibrium. So the system will respond by absorbing that excess heat. Absorbing means it will favor endothermic reaction. So positions of equilibrium will shift to endothermic reaction, either left to right or right to left, depending on your chemical equilibrium. So how to determine which side is endothermic, which side is exothermic? You need to refer to the value of enthalpy given. So enthalpy given is to show forward reaction. If the enthalpy is negative, it means the forward reaction is exothermic. If the enthalpy value is positive, that means the forward reaction is endothermic. Okay, so you don't need to memorize in which direction it will shift, left to right or right to left. You just need to focus what will happen when we increase the temperature, which reaction is favorable, and why does it happen. Okay, and then in the terms of Kc or Kb value, since it involves changing in temperature, Kc or Kb value will change as well. So how to know either your K will increase or decrease? So it depends again on the directions of equilibrium. If we produce more product, means our value of K will increase. But if we decrease the amount of product, that means our K will decrease. Okay guys, so let's continue with changes in pressure, which is your third factor in the disturbance towards your chemical in equilibrium. Okay, so changes in pressure will only affect the gaseous component that is present in your chemical equilibrium. Again, chemical equilibrium can only be disturbed when there is changes in the gaseous component, either in the terms of concentrations or in the terms of pressure. So temperature will only affect everything. Okay, so changes in pressure, we have two different cases. Either we increase the pressure or we decrease the pressure. Okay, so we have to determine the number of mole of the gaseous component at both reactant and product side, because the number of moles we're going to compare between these two, because it will determine in which direction does the position of equilibrium will shift to. Alright, so increasing pressure will cause the systems in equilibrium to try to restore the original pressure of the system. So how? It will try to reduce the pressure increment by shifting to the side that has less mole of gas molecule. So less mole of gas molecule. Okay, but if we decrease the pressure of the systems, it will try to reproduce more pressure by increasing the pressure, so it will shift to the side with more moles of gas molecule. So it depends on which side of your reactants or your product has more moles of gases. So how are we going to find out the number of moles for your gaseous molecule? Okay, so let's look at this example. So predict the effect of increasing volume on the equilibrium given below. So explain your answers. Okay, so let's first try to find out the number of mole for your reactants and your product. Okay, so I have 1 mole of carbon monoxide here and 1 mole of water molecule here. Both of them are gaseous component. So 1 plus 1, so on my reactant side, n equals to 2. Okay, on my product side, I have 1 mole of carbon dioxide and 1 mole of hydrogen gases. So in total, I have N equals to 2. Okay, so increasing volume will causes your pressure to decrease, because this one is a container. So initially we have this piston and we have trapped a lot of gases here. So initially it's like this, then after we increase the volume, so the piston is moved upwards. So gas molecules still the same amount, but now it have more empty spaces between them. Okay, so decreasing in pressure. So disturbance is increasing volume means decreasing pressure. Okay, so by right, from the previous slide, we says that when we decrease the pressure, systems will respond to shift by producing more pressure until an equilibrium is established. So POE will shift to the side with more mole of gas. But if we compare the gas molecules here, so on our reactant side, we have 2 moles of gases component, and on my product side, I have another 2 moles of product gases component. So in this example, I have similar number of moles for both reactants and product. So that means there will be no change in equilibrium. Since the system, this is the chemical equilibrium, EQ stands for equilibrium, contain the same number of moles for both sides. Therefore, no changes in the positions of equilibrium will take place. Okay, so in this example, we have both side reactants and products to have same number of moles of gases component. So it will give you no effect towards chemical equilibrium even though we increase the volume. Okay, so let's look at a different example. Alright, so here predict the effect of increasing pressure on the equilibrium given below. Explain your answers. Okay, increasing pressure. Okay, so the disturbance is increasing pressure. Increasing pressure. So that means we write down first, the system will respond to reduce the pressure, to reduce the pressure until an equilibrium is re-established. Okay, so POE, positions of equilibrium, will shift to the side with more mole, if it's increasing pressure to the side with less moles of gas molecules. Okay, so let's look at the chemical equilibrium given here. So we have 1 moles of ammonia gases plus 2 moles of oxygen gases on my reactant side. That means in total 1 plus 2, 3 moles. Whereas in my product, I have 1 moles of nitric acid, which is in the liquid, and 1 moles of water, which is in the liquid as well. So that means 0 moles of gases component. So which side has lesser mole of gases? Definitely on your right side. So direction, positions of equilibrium will shift from right to Okay, so let's look at this example. So the question asks to predict the effect of increasing pressure on the equilibrium given below. So our disturbance in this example is increasing pressure. Okay, so first let's predict what will happen when the pressure of the system is being increased. So system will respond to reduce the pressure by shifting to the side that produce less or more. We want to reduce the pressure, so definitely we want to have less moles of gas molecules. So to the side that produce less moles of gas molecules. So in which direction does the position of equilibrium will shift to? Depends on the chemical equilibrium given. So let's look at the chemical equilibrium given, and let's determine the number of moles for both reactants and product in the terms of gaseous component. So in the reactant side, I have 1 mole of ammonia gases and 2 moles of oxygen gases. So in total here, I have 3 moles of gaseous component on my reactant side, whereas I have 1 mole of nitric acid, which is in the liquid phase, and water in other liquid phases. So both are liquid phases. That means in total I have 0 moles of gaseous component at my product side. So that means we want to decrease the increasing pressure by shifting to the side with less mole of gas molecules. So your positions of equilibrium will shift from left to right until an equilibrium is established, which is Q equals to T. Okay. So let's look for another example, which this should be question 9. We predict the effect of decreasing volume on the equilibrium given below. Alright, so decreasing volume. So that is our disturbance. What will happen to the pressure when you decrease the volume? Try to recap on your ideal gas behavior. What will happen when you decrease the volume of the systems? What will happen to the pressure of the systems? Okay, so let's draw some sketch. Okay, this one. Okay, so we have here a gas molecule trapped in a container, and this piston is this high, and then we lower the piston so that we can decrease the volume of the container. So the gas molecules become close to each other, become closer instead of far apart from each other, so lesser empty spaces between them. That means we have a high pressure system. So when high pressure systems happen, what will happen? Okay, so system will try to reduce the pressure by shifting to the side which produce less or more mole of gas. Okay, we want to reduce the pressure. That means we're going to shift to produce less moles of gas molecule. Okay, so let's first calculate the number of mole of gaseous molecule in this example. So 1 carbon in the solid phase and 1 water in the gaseous phase. So in my reactant sites, I only have 1 mole of gaseous component. Okay, whereas I have 1 mole of carbon monoxide and 1 mole of hydrogen gases in the product component. So in total, I have 2 moles of gases. Okay, so which side has less mole of gas molecule? It's on my left side, which is our reactant side. So positions of equilibrium will shift from right to left until an equilibrium is re-established, which Q equals to K. Okay, so that's all for your changes in pressure. So changes in pressure is related with the changes in volume, which volume is inversely proportional with your pressure. So increasing volume will decrease the pressure of the systems, but increasing the volume will decrease the pressure of the systems. Decreasing the volume will increase the pressure of the systems. And the changes in the pressure will affect the systems in equilibrium towards the gases component. So if we have high pressure, it will prefer to produce, if we have high pressure systems, so the system will shift to the side that can reduce the effect of increasing pressure by shifting to the side with less number of mole of gas molecules. But if we decrease the pressure of the system, so the systems will try to increase again the pressure of the system. So it will shift to the side which produce more mole of gas molecules. Okay guys, so let's proceed our lesson with addition of inert gas. So there are two conditions. Either you add your inert gas at constant volume or in addition of your inert gas at constant pressure. So as a recap, let's remember examples of inert gas that is present in this world, helium, neon, and argon. So they are all group 18 elements. Okay, so let's first look at additions of inert gas at constant volume. So we have this chemical equilibrium, which is hydrogen reacting with iodine gas to produce hydrogen iodide. Okay, so in order to find out either the addition of this inert gas will affect your systems in equilibrium, you have to figure out either these additions of inert gas alter or change the partial pressure of the individual gases component that is initially present in your system. Okay, so for example, in this one, we are adding inert gas at the constant volume. So the volume of the container is remain constant, but the pressure does not remain constant. The pressure here means the total pressure of the gas. Okay, so initially, we have partial pressure of hydrogen gas plus partial pressure of iodine gas and partial pressure of hydrogen iodide gas, which sum up to becomes the total pressure of the gases component present in the container. But after additions of an inert gas, okay, so total pressure now we have hydrogen gas plus iodine gas plus HI gas and plus inert gas. All the partial pressure for each of these four gases component adding up and becomes the total pressure. So this one addition at constant volume, but it doesn't state that at constant pressure of the entire system. Therefore, the total pressure of the system will just add up the partial pressure of the individual gases. So that means no changes in the partial pressure of each gases that initially present, which is your hydrogen, iodine, and hydrogen iodide. As a result, there is no changes in the positions of equilibrium because no changes in the partial pressure of individual gas component that is initially present in your container. But it will become a different cases when we are dealing with addition of inert gas at constant pressure, because the total pressure must be kept constant no matter how many inert gas you are adding in. Okay, so for example, if the total pressure of the system is 15 atm, okay, so initial in this container, I have hydrogen, iodine as well as hydrogen iodide. So P total is 15 atm, and this 15 atm I shared between P hydrogen, partial pressure of my hydrogen, partial pressure of iodine, and partial pressure of my HI. Let's say, okay, so my HI, it is 10 atm, whereas this one is 2.5 atm, and this iodine gas has 2.5 atm. Let's say that is the initial partial pressure of each of the gases, okay, because it's 15 atm in the total. Alright, but now after additions of the inert gas, I still have to keep constant my total pressure, which is 15 atm. But now we have 4 different gases. That means the 15 atm total pressure need to be divided among these 4 different gases. So automatically, the initial partial pressure of hydrogen from 2.5 atm will drop to lesser than 2.5 atm. Same goes on with my iodine gases, which is less than 2.5 atm, and my hydrogen iodide gases, which should be less than 10 atm, because we want to give some of the partial pressure to the inert gas that is present. Okay, we need to increase the partial pressure of the individual gas again. So what will happen? So the system will respond to increase the partial pressure of the hydrogen, iodine, and Hi by shifting the system towards the side that produce more moles of gas molecules. Alright, so let's discuss on this one to understand more about addition of inert gas. So what would be the effect of adding neon gas at constant pressure and volume towards the equilibrium? Okay, so first let's talk about constant volume. So additions of inert gas at constant volume, like we said before, will not change the partial pressure of each gases present. Partial pressure of individual gases component that is present. Initially, therefore, no change in position of equilibrium, so POE. It will be a different cases when we adding neon gas at constant pressure, because we need to keep constant the total pressure of the system. Okay, so we have here 3 moles of oxygen gases, so 3 moles of gases at your reactant site and 2 moles of gases at the product site. So additions of inert gas at constant pressure will cause the partial pressure of the gases component, okay, partial pressure of the gases component initially present to be decreasing. Initially present to decrease. Okay, what will happen? The system will respond by increasing the pressure of the system. Okay, so if increasing the pressure of the system, it will shift to which side? Less number of moles of gas molecules or more gases molecules? Okay, so it will shift by shifting to the side with more moles of gas molecules. Okay, so based on the chemical equilibrium given, we have 3 moles of gases component on the reactant and 2 moles of gases component on the product side. Therefore, your POE will shift from left to right until an equilibrium is established and Q equals to K. Alright, so last one for today, which is addition of catalyst. So catalyst is not something that can be a disturbance towards your chemical equilibrium. So catalyst is just a special substance which is used to speed up a chemical reaction by providing an alternative pathway with lower activation energy. So you're going to understand more about catalysts later on in your semester 2 under the topic of reaction kinetics as well as in the thermochemistry. Okay, so catalysts will speed up both forward and reverse reaction at equal rates. Therefore, it will give you no effect towards the positions of equilibrium and no changes in the value of your equilibrium constant. Okay, so I have discussed with you all the disturbance factor that might affect the systems in chemical equilibrium. Therefore, this is the final quiz for this week. So you need to answer all of these questions and I'm going to give the marking scheme, and you need to compare your answers with the answers I give, and you need to mark your answers, and you need to submit your answers which already marked in the Google Classroom. Okay, see you guys in our third hour tutorials. Bye bye and take care.